Hi everyone, my name is Federico and I am a .NET software engineer that has been working in Cognizant Softvision for about 2 years. In this talk, I wanted to show you something that I have been working on for communicating an application with external APIs using EventGrid in an Azure serverless application. This work was done in one of the projects that we have. So what you're about to see was not only developed as a POC, but it was also deployed, and nowadays it is working in one of our clients' applications. So let's begin. The first thing that we are going to talk about is the scenario that was in front of the team. Before talking about the actual approach to the solution we decided to work on, we need to look at what we had available, which in this case is the tech stack that the client wanted to implement. This is the tech stack that we have to use in our application. So that limits the tools and technologies available to us in the project. The client was implementing in all their applications what is called a serverless architecture in Azure. So we went with that approach. So what does serverless architecture mean? Let's take a quick look at it. When understanding the definition of serverless computing, it's important to note that servers still run code. The serverless name is due to the fact that tasks associated with provisioning and managing the infrastructure are invisible to us. This approach allows us to focus more on the business logic and to deliver more value to the business. What you can see here is an official Microsoft example of how we can build a serverless architecture. And you can see that it's pretty similar to what we have built for our client. There is a single web page application that is connected to the function apps using API management for routing the calls from the browser to the different function apps, which in turn connect to the databases the application has to save or retrieve data. Microsoft offers a variety of architecture patterns for developing applications. In our case, we used serverless functions for our backend. Now that we have talked about it, let's see what Azure Function is. Azure Functions is a cloud service that provides all the continually updated infrastructure and resources needed to run our applications. We can use functions to build web APIs, respond to database changes, process IoT streams, manage message queues, and more. Azure Functions allows us to implement our code logic into readily available blocks of code. These code blocks are the ones called functions. Different functions can run anytime we need to respond to critical events. As requests increase, Azure Functions meets the demand with as many resources and function instances as necessary, but only while needed. As requests fall, any extra resources and application instances drop off automatically. There are different functions that we can use according to our needs. In our case, we use HTTP trigger functions that act as API endpoints, event trigger functions that receives calls from EventGrid, and blob trigger functions in order to know whenever a dead letter was created. So since we mentioned it, let's see what EventGrid is. EventGrid is an Azure resource that we can use to trigger events based on what's happening in our application. There are several ways to trigger these events, and EventGrid is able to call different services, as we will see in the next slide. As you can see, there are several sources that can trigger an event, and different event handlers that we can use according to our needs. For the application that we have built, we used event hubs to trigger an Azure function that was the one in charge of communicating with the external APIs. Now, this is the feature that we needed to make our solution work. The automatic retries that EventGrid provides are super useful, since the team doesn't have to worry about what happens when a call to an external API endpoint fails. And if for some reason the external endpoint fails, after the multiple retries attempt, EventGrid can save the failed event in an Azure Blob storage so that we can know what happened with that call. And last but not least, let's take a look at what Azure Blob Storage. Azure Blob Storage is a highly scalable and secure object storage for our cloud-native workloads, files, data lakes, high-performance computing, and machine learning. In the case of our application, we only need a storage account to save any dead letter generated by EventGrid whenever, after an amount of retries, the communication with external API was not possible. So, now that we have talked about what we had, what the client wanted, and the different resources provided by Azure that could help us, let's talk about what we were working on. So, going back to our architecture diagram, what we needed to implement was, whenever a connection with an external API failed for whatever reason, for example, site down for maintenance, changes in parameters, changes in the payload, etc., a way to automatically retry to connect, with a number of retries before canceling the operation. And if for some reason that call was not possible to make, a way for us to know what happened. So, we needed several things in order to achieve this. A way to ensure communication with the external APIs, sync those communications in order to stay in line with the business requirements, a method to retry to connect a number of times if anything failed, and if after many retries we were unable to communicate with the APIs, a way to get notification about this. So, how we did put everything together? Next, we will see how to implement this solution. It's important to know that in order to prevent sensitive data to be leaked, we are going to see several screenshots of how to set the environment up and running and how to test each component separately. But we are not going to see live code running or logging in an Azure portal. Let's start. First, in our portal, we need to create an EventGrid topic resource. Once we click Create, we just need to select our subscription, the resource group that we want the topic in, a name to it, a region, and we are set. This is pretty easy to do. Once our EventGrid topic is created, we need to get two things in order for our application to connect with it: the topic endpoint and the access keys. These values are needed in order to our code to connect when a new event is sent to the EventGrid topic. These all are sample values. Everything was deleted after the screenshot, so nothing to worry about. So now that we have our resource deployed and we have the connection keys, it's time to look at the code that will connect to the EventGrid topic. First, we need to install the Microsoft.Azure.EventGrid library in order to work with some classes that we need: the EventGrid client, the topic credentials, and the EventGrid event classes. For this example, I created a class that sets a new EventGrid event, receives the credentials that we copied in the slide before, and passes them to the properties, creates a new client with those credentials, and sets the serialization settings. I also add a method for triggering the event, which receives as parameters the event type and the payload we want to send to the EventGrid topic. In this method, we create the new event, set everything up, and publish the new event so that our EventGrid topic can read it. Next, we set up a class with the fields the payload needs in order to send information to the Event Hub. And finally, something that will connect with the EventGrid topic. Load the event with the payload and send the new event to the portal. For demo purposes, I created an HTTP trigger Azure function, since our solution it consisted on several HTTP trigger functions that act as endpoints. In this case, if someone calls the run event trigger endpoint, this would execute the code and it will send the event to the EventGrid topic. So everything is ready to send an event to the EventGrid. Now we need something to trigger based on this event. As you can see, the function has every piece of code necessary to publish the new event: topic credentials, the event type, which is very important, and you will see it next. In this case, I called it PW EventGrid demo, a payload, and a call to event class with the trigger method that will send everything to the EventGrid topic. Now, we need an Azure function that is able to receive what the EventGrid topic is sending in order to process it. For this demo, I have created an EventGrid trigger Azure function that will be listening to the EventGrid triggers for a specific event type, which in this case will be the one that we send with the event, the one called PW EventGrid demo that we saw in the slide before. It's important to know that once we have created our function, this one, we need to publish it. This is in order to set up our EventGrid topic as subscription, which in this case will consist on an event type and something to trigger, which in this case is this function. So let's configure the subscription in the event, to the event and the trigger. We have to go back to the Azure portal, and in the EventGrid topic, we have to click on Event Subscription. When creating an event subscription, we need to fill a name, an event schema, which will be EventGrid schema by default, an event type, which is important to define which event types this subscription will be paying attention to, so that we add the one that we are passing as a parameter in the function we saw before. Without this, nothing will be triggered, so it's important to pay attention to this field. It can be updated, so no big deal if we mistype it. And as you can see, we can also add more event types that can trigger the same event trigger. Once we have that, we need to select the endpoint type, in our case an Azure function. When we select the endpoint type, new fields will appear for us to complete to indicate which is the function endpoint. This is why we need to have our event trigger function already deployed in the portal. Without it, we cannot select the function that we need to trigger. Next, if we go to the Advanced Features tab on the upper left, we can see some things that we need to specify in order for this to work. The dead lettering, retry policies, and if we need, event subscription expiration time. The most important configuration for us in this case is to enable dead lettering and set how many attempts we are going to try to communicate. With everything set up, we click Create. This is on the bottom left, not in the screenshot, and everything will be deployed in our portal. This is an example of a dead letter that EventGrid stores in our Azure Blob containers. With this information, we can know which subscription failed and what data it contained, so we can further debug our application to understand why the message was not delivered. The last function that we need in order to know whenever a dead letter was created is a blob triggered function. In this example, it just logs whatever has been uploaded to the container, but it's more than enough for us to know that everything is working. So, once everything is set up on both the portal and the backend, we can start testing the application. Since it's pretty difficult to do a live demo of this, mainly because it takes some time for the events to reach EventGrid and for it to trigger the functions, I have captured these steps for you to see. When we start the application, you can see that we have 3 functions available, but only one can be called like an API endpoint. That is our HTTP trigger function. When we call that endpoint, the code that we send the event to the EventGrid topic will execute. Here, you can see that EventGrid received an event, and that event triggered the Azure function that we set up before. Below, you can see some details about the packages received by the EventGrid topic. Published events, failed events, delivered events, etc. In our case, we can see that the EventGrid topic received an event and published it successfully. So how do we test the event trigger function? For testing this function, we can simulate a call from the EventGrid topic with some help from Postman. In order to do that, we need to write a special URL for calling this type of functions, which is the one you can see in the screenshot. We also need to add a key header in order for this to work. It's the one in red that you can see. It's important to know that without this, we cannot simulate the call. We can also simulate the data coming from EventGrid, including the payload. This is a standard JSON that EventGrid sends to the trigger. So we hit send, and when the code receives our call from Postman, we can see that it received it successfully, and we can see the simulated payload as we would receive it directly from EventGrid. And to test the blob trigger function, we just need to upload something to our blob trigger, to our blob container, and wait a few minutes. Our function will be listening for new files in the container, and once it gets the information, the function will trigger. As you can see, I uploaded the dead letter example that I showed you before, and we receive it in our function. For this demo, I'm only checking that we actually received the data. But in the actual application where this was deployed, we're using the dead letter information to inform the client that their externals API are not working, and we are including every data that we feel they need to make their lives easier. And with that, we have come to the end of the presentation. I hope this information was helpful to you, and if you have any questions, feel free to ask.
Hi, Fede. We don't have questions.
Okay.
But we have a lot of reactions, so cool talk.
Okay, thank you. And with that, a big thank you to you all. A big thank you to Cognizant Softvision for letting me be part of this beautiful event. And I sincerely hope that this information was helpful to you and you can use it in the future. And if you had to use it, please do not hesitate of contacting me via email, Slack, wherever. I am at your disposal. So thank you very much.